This is the Registered Behavior Technician course presented by Shaza Attar. The course content was created by Shaza Attar and is the property of Autism Therapy and Training, Inc. All rights are reserved. This training program is based on the Behavior Analyst Certification Board 2018 RBT Task List 2nd Edition and is designed to meet the 40-hour training requirement for the RBT credential. The program is offered independent of the BACB. Remember, in each class, we will have our active listening, a quiz, and a competency assessment.
Hi everyone. Our topic today is the continuation of Task List A, Section 5, which is entering data and updating graphs. As I mentioned in our measurement class, taking data is crucial. We are essentially gathering information so that we can later analyze it. Think of a police investigation. Police don't go to a crime scene, look at it, and take someone into custody. That would be careless and unethical and unprofessional. The investigation unit needs to gather evidence before they analyze it and come up with a suspect. Data collection is similar in many ways. You need to observe the client, behavior, and environment. Take data, then graph it. We'll be discussing how to enter data after you've collected it and discuss how to graph it. I'll outline the different types of graphs you may use in practice. So let's get started. Graphs are great because they are a visual representation of the data collected. Most people need something to look at in order to make sense of all the numbers. If I said, yesterday Johnny had 5 hits, and on Tuesday he had 15, and on Thursday he had 9, and on Saturday he had 8, that would be so hard to follow and see the direction of the behavior, and so on. But seeing it is just so much easier. So the first thing that we need to do is take data using the correct method of measurement, which was discussed in our measurement class. Whether you're taking continuous measurement, such as frequency, duration, latency, inner response time, or discontinuous measurement, such as partial interval, whole interval, or momentary time sampling, you need the data first before you can make treatment plans or recommendations. As a supervisor, it's very difficult for me to help my team and learners when a therapist says, Johnny's biting his shirt and it's been a big problem during teaching. What should I do? Without data and seeing how many times it's happening, I won't know whether or not it truly is a problem. Right now, I want you to understand the importance of data, measuring it and graphing it, and how it benefits the treatment decisions, so that we can start looking at why they are engaging in this behavior and what to do, so that we can compare the baseline data without treatment to the treatment phase. So when you see a behavior happening, you need to write it down. Remember, you can't store all the data in your mind. It needs to be tracked on a data sheet. That is also beneficial because if graphing errors occurred, you can always go back to the raw data to see what was written. Next, you'll need to plot the data on your graph, and finally, this can be interpreted with your supervisor. Everyone on the treatment team has a responsibility. Your supervisor is responsible for assessing the learners, designing programs and protocols, overseeing the team, and coaching, and so on. Your role as an RBT is an important one. You'll need to collect the data, record it on a tracking sheet, transfer the data onto a graph, update all the programs and the graphs, which may be graphed daily or weekly. Graph daily behaviors and update them regularly. Think of your data collection and graphs as a work of art. You work directly with the learner and shape them into the learner they are each day. The data and graphs are the visual products that can be admired by others. As you could probably tell, graphs are very exciting for me. I love sitting with a therapist and reviewing the graph, especially when we see progress. It's even better when we can share those results with parents. Parents can look at the graphs and see their child's progress over time. How fast or slow. Sometimes you can see a behavior improving slowly, then suddenly improve very quickly. We saw this with a little boy. Let's call him Sammy. He had a very hard time learning to imitate actions. We took data on his trials, and the first couple of weeks his percentages were quite low. After mastering about 3 or 4 of the skills, we started to see his learning improve. The percentage was higher in less time. We could visually see that he started understanding the imitation requirements, which was great. I want to talk about 2 types of graphs that you'll probably use most. Firstly, line graphs, and secondly, cumulative records or cumulative graphs. Before I talk about how to input the data, I want to review some terms you'll need to know. Here is what a line graph looks like. It can have 1 or multiple lines. The line graph is simple to use. It's used throughout the field and it's easy to read. You've seen these graphs everywhere. It's used to graph frequency of a behavior that you want to decrease or behaviors to increase. Line graphs can also be used to graph duration data such as minutes of exercising or crying. They're used to graph programs such as reading, math, requesting, vocalization, cooperation, and so on. It's used for behaviors you want to increase and also used for behaviors, problem behaviors that you want to decrease, such as disruptive behaviors, aggression, self-injurious behaviors, and so on. Okay, I want you to close your eyes for a moment. We're going to do a little activity. Be sure they're closed. Now rest your head down or back so you're relaxed. Ready? How long was the baby crying? If you said about 10 seconds, then you were amazing and you were probably counting in your head. But if you guessed anything longer than 20 seconds, it's probably because it felt like the baby was crying forever. I'll come back to this activity in a couple of minutes. Line graphs typically have baseline data, which is the no treatment phase. It is what the behavior looks like in the current time without intervention. Baseline data helps us see what the behavior is looking like, how many times it's occurring, how long, and so on. It also tells us whether the behavior is a problem or not. Many times in practice, therapists or parents will come to me and say, "Little Billy is hitting us and it's increasing by the minute." When we take baseline data, we find that the behavior occurs twice in a day, in like a 6-hour day, let's say. Sometimes the behavior seems more frequent or long-lasting because of our perception. Going back to our baby crying example, when a child is crying, we can perceive it to be much worse than it is because the behavior is bothersome to us. So therefore, taking the data will help us see the reality of the behavior. In practice, baseline data may not always be taken, depending on the behavior and the severity. Sometimes we have to jump into treatment to ensure the client is safe, but in many cases, we can take baseline data. This may be a few sessions to gather information on that behavior. Treatment data shows us the effect of the treatment on that behavior. Once a treatment plan has been designed and implemented, we can watch and see how it impacts the behavior. We can make decisions about the effectiveness of that program or protocol. Something to watch out for, since I see this with many therapists, teachers, and parents, is not to jump to conclusions, saying that the treatment isn't working or is working without reviewing the data with your supervisor or behavior analyst. I've had therapists tell me that the child is doing so well and they think that a program is ready to be mastered. And when I review the data with them, we see that the child still needs more work in that area. Or the therapist says that an intervention is not working and the child isn't gaining the skills, and they're legitimately concerned. When we look at the data, I show them that the program has only been running for 2 days. In this case, we'd need to give the child time to learn the skill. So let's take a quick stretch break and do a Scrabble word. So here's another favorite one of mine. The word is xi, which is spelled X-I. It's the 14th letter of the Greek alphabet. Let's move into the parts of a line graph. There is the x-axis, which runs horizontally, and it shows the passage of time, such as session, date, month, and so on. The y-axis is the vertical line, which shows the range of values of the dependent variable, such as the number of times a behavior occurred or the duration. It's the behavior being measured. And here's our beautiful y-axis in red. Condition lines or phase lines show us changes in time which can be represented by a solid or dashed line. The solid line showing major changes and a dashed line showing minor changes. So if a learner's session times change or the child was sick, you can use a condition line to indicate that there was a change. If there were program changes, a condition line can be drawn here too. The importance of the condition line is to show us that due to some change in the environment or event change, the behavior improved or declined. For example, suppose a child in the program was coming 5 days a week and then his parents changed his schedule to only 3 times a week. The learner's rate of learning and progress could be affected because of this change. The condition line will visually show this on the graph. Condition labels are descriptive phrases printed on the top of the graph that explain the condition changes. This could be baseline, treatment, program change, sick, and so on. Here, you can see how the condition labels are set up with the condition lines. The data points connects the target behavior with the time of observation. For example, the behavior is hitting and it occurred 5 times on Tuesday. So we need to indicate this by finding 5 on the y-axis and Tuesday on the x-axis. You can use a geometric shape like a circle, square, or triangle to plot your point. The data path is the line that connects all the data points. This represents a path for the target behavior. The data path can be on a slope down or on a rise. Graphs can show variability, stability, levels, and trends. Let me show you what each one could look like. This graph here shows variability. The data is not stable. It's moving up and down. This is a graph of concern and should be brought up to your supervisor's attention. This is a stability graph. It's not showing progress nor decline, so something needs to be implemented potentially to increase or decrease it. Again, another graph to show your supervisor and discuss it with them. This is a graph that shows high levels. If it were a behavior you were trying to increase, this would be good. If it were a problem behavior that you don't want at high levels, you would need to speak to your supervisor about this graph. This graph shows low levels. Again, if it were behavior we wanted to decrease, such as aggression or some other problem behavior, then that would be great. But if it was a skill that you were trying to increase, then you would again need to address this with your supervisor. This graph shows an increasing trend, while this graph shows a decreasing trend. This graph shows a no trend, which means the behavior is flatlining. Again, this is a graph of concern. Behaviors should never flatline. If they are, that means the program or protocol are not effective. The y-axis scale should always start at 0. It can go up by singles, 2s, 5s, 10s, or other multiples depending on the data being collected. Before we start our practice, let's do another Scrabble word and stretch. The next word is cat, which is spelled Q-A-T. These are the leaves of an Arabian shrub. All right, now let's jump into some practice. Which graph shows the data point? A or B? And the correct response is B. Which graph shows the condition label, A or B? And the correct response is B. Well done. Which graph shows the x-axis, A or B? And the correct response is A. Way to go. Which graph shows the condition line? A or B? And the correct response is A. Which graph shows the y-axis? A or B? And the correct response is B. Fantastic. Which graph is incorrect? A, B, or C? And the correct response is C. Data points should never cross over a condition line. When you collect frequency or rate data, you will use a tally counter or clicker, timer, or some other instrument to gather that information. That information needs to be put somewhere. When you're working with your learner, you need your data sheet to track the behavior. I'm going to go through how to input the data using numbers or Excel. For those that are using paper and pencil tracking and graphing, this may not apply. At our center, we are paperless to a certain degree and therefore use numbers to input our data and graph it, which is so much easier. So I'll show it to you and it'll be so quick and easy. If you use Excel or numbers, you can create a table and on the left-hand side put the dates, and on the right-hand side you would put the frequency. If you were graphing this using Excel and numbers, you would simply click on the charts, find the line graph, and it would plot your points on its own. So let's practice the graphing. I've given you some blank graphs. Please print copies and use them for these exercises. You want to put the correct labels on the Y and X axis. Your Y scale will start at 0 and end at 30, going up by 5s. The next slide shows you the dates so you can indicate them on your graph and plot your points. I've given you some baseline data and the data points are 25, 23, 22, and 26. Take a few moments to graph this. Feel free to pause and take some time. And if you're stuck, don't worry about it because I'm going to walk you through it. But I want to give you a chance to try it on your own first. So what does your graph look like? So here you can see that I've added the range on the y-axis, 0 to 30, and it goes up by 5s. And the x-axis, the horizontal line, I've indicated the dates 15, 16, 17, and 18. The next slide, you can see that I've labeled the axis. The y-axis is the behavior that we're measuring, which is hitting, and the x-axis is dates, which is the passage of time. In this next slide, I've labeled the baseline and plotted the first point, which is at 25 on October 15th. So you should have a point there on your graph as well. Your next point on October 16th and the amount of 23. So now you can see here that plotting your data points using a scale that goes up by 5s may be difficult to see where you're placing the data point. So you may need to consider the scale you're going to use based on the behavior that you're collecting. I typically like to go up by 2s, but it all depends on the number of behaviors that you are having per day. So this needs to be determined with your supervisor. In this case, you're still able to plot your points, so it's not a big deal, but something I want you to bring up to your supervisor or to think about when you're graphing. The next point plotted is 22 on October 17th. And lastly, 26 on October 18th. So your graph should look something like this by the end. Is that what you got? So now let's plot some treatment points. I've given you some data here, 19, 14, 9, and 3. What would your graph look like? Take a moment to graph this and see if your graph looks similar to the next slide. So if you graph this correctly, you should have a condition line, and I usually use a dashed line in practice because most changes are minor. But you can definitely speak to your supervisor about this, and it really depends, whether you're using a solid or dashed line, depending on the changes for that client. So your supervisor will help you with that. I also added the treatment label on the top of the graph, which is followed by the treatment data points. So 19, 14, 9, and 3. So your graph should look like this. If it does, way to go. If it doesn't, be sure to double check your range, dates, and just make sure you put the data points in the right spot in your condition line and labels. See where you went wrong and be sure to correct it before the next time. This is a lot of information. So I want you to take a moment and I want you to take a break and let's go through another Scrabble word. So the word is ew, spelled E-E-E-W. And of course, this was a bit of a surprise for me when I was playing Scrabble. I put it on the board and it actually worked. So there you go, your next word when you're playing Scrabble. All right, so let's do the same thing here, but graph rate of behavior. Keep the range and x-axis the same. Remember, with rate, you will take the number of the behavior divided by the number of hours. For example, Tommy had 40 hits in a 4-hour session. So here is your baseline data, the number of times Tommy engaged in hitting, and the length of the session. Take a few minutes and indicate the rate of the behavior. Remember, take 25 divided by 3. If you get a point value, you can round it up to the nearest whole number. For example, if you get 12.2, you can round it to 12, or 12.7, you can round it to 13. Let's see what you got. So your rate should be 8.3, 11.5, 11, and 8.6. Now I want you to graph that. What does your graph look like? All right, let's break it down step by step to ensure you did it right. Remember, your labels, y-axis is the behavior, which is the hits, x-axis is the dates, and indicate your baseline on the top of your graph. The reason why I keep reminding you of this and walking you through it is because it gets forgotten a lot in practice. Therapists will graph their points but forget all about the labels, and I find myself often reminding therapists of this. It's hard to understand a graph when parts are missing. So this next slide shows the data points graphed, and your graph should look like this. In slow motion, this is how I graphed it. When you're graphing, try to stick to one color if you're using paper and pen. Don't go from blue to black. I like to just use black. It's easier for me. So let's get some treatment points added to the graph. Here is the data. Take a moment to graph it. Remember to get the rate of this behavior. And there are your points. Now again, look at the range. It would have been better to use a Y scale that goes up by 2s. It would be much easier to read. When graphing duration data or data that is represented in seconds, minutes, or hours, your graph y-axis will display the number of minutes or total number of minutes of that behavior. Here's a graph that shows how it should look when you may be graphing a behavior such as vocal scripting. The y-axis is labeled as number of seconds of scripting. The behavior occurred 130 seconds for that day. So here is some data. Enter the total number of minutes the learner engaged in crying. Simply add the numbers together for each day. For example, on October 15th, add 2 minutes plus 5 plus 7 plus 8 plus 6. All right, I'll give you a minute. And your results should be 28 minutes, 23 minutes, 29 minutes, and 26 minutes. Here's the graph and the data. Your graph should look like this. Data can be graphed using percentage as well. The number of occurrences or trials are divided by the number of total trials. For example, a behavior occurred 5 times out of 10 trials. You would then divide 5 by 10, which equals 0.5, and multiply it by 100, which equals 50%. Percentage graphs range from 0 to 100, and the y-axis label indicates the percentage of the target behavior. For example, percentage of words read correctly. Here's another Scrabble word for you. Did you know that is a form of lava spelled A-A? All right, moving on. Time sampling data can also be graphed using percentage. This is how we would graph it. The RBT took partial interval data on vocal scripting. Here's the data. How many occurrences occurred on each day? For March 11th, there was an occurrence on the 10, 40, 50, 60-second interval. Therefore, there were 4 occurrences out of the 6 trials. Do the same for March 12th, 13th, and 14th. The answers are on the next slide, but take a moment and input this data. You should have gotten 4 out of 6, 5 out of 6, 3 out of 6, and 4 out of 6. Now take this information and convert it into percentage data. Here are the percentages. Is that what you got? Now plot the percentages on your graph. Take a moment to do so. The graph should look like this. Just to wrap up line graphs before we go into cumulative records, keep in mind that a line graph can go up or down so that you can graph behaviors that may increase or decrease. Which graph shows the following data points? 9, 7, 4, 5. A, B, C, or D? And the correct response is C. Way to go. What is missing in this graph? A, condition labels, B, data points, C, condition lines, or D, y-axis range? And the correct response is C, condition lines. What part of the graph indicates a change has occurred? A, x-axis, B, condition line, C, trend line, or D, data path? And the correct response is B, condition line. Well done. What part of the graph shows passage of time? A, x-axis, B, condition line, C, trend line, or D, data path? And the correct response is A, x-axis. Fantastic. What should the y-axis be labeled? A, sessions, B, number of hits, C, days, or D, nothing? And the correct response is B, number of hits. What should the x-axis be labeled? A, minutes of crying, B, number of hits, C, days, or D, nothing? And the correct response is C, days. Way to go. What is wrong with the following graph? A, no condition lines, B, wrong x-axis label, C, wrong y-axis label, or D, condition line? And the correct response is D, the condition line. Remember, the data points should never cross over the condition line. So that condition line should not be there, or the data points should not be connected to one another. Cumulative records, also known as cumulative graphs, are great graphs for plotting skill acquisition programs. Cumulative meaning an increase in quantity by successive additions, meaning the number of occurrences are added to the occurrences plotted from previous sessions. These graphs are not ideal for problem behaviors. This graph is used to display a behavior that one wants to increase. It always goes up and never goes down. The y-axis shows the number of responses or behavior of interest. Cumulative graphs show the overall responses per week or session. For example, in practice, we use cumulative graphs to show the number of skills acquired per week in a variety of programs, such as math or reading, matching, and so on. The steeper the slope on the graph indicates a rapid rate of acquisition. These graphs can also show gradual or slow increases. Cumulative graphs or records can also plateau, which is when we see a flat line. Here is an example of the different rates of acquisition. The first line with the circle data points shows the steep slope, the kind of learning you'd like to see. The second line with the triangle data points shows a gradual increase. And the last line with the square data points shows a slow rate of learning with some flatlining. This is an example of a graph I like to show families when enrolling into an ABA program. If families do about 6 to 9 hours a week, the rate of acquisition is very slow for most kids. It depends on how many programs are in place, how much practice they get, and so on. But it gives parents an idea of how the hours may impact the progress. In practice, we use cumulative records when collecting probe data. A cold probe is a pretest of a skill. A therapist would indicate Y for yes, that the child was able to do without prompting, or N for no, that the child was unable to do it independently. This is often done daily before teaching occurs. A program will specify what the mastery criterion is. That is, how many yeses a child needs to acquire the skill. Let's suppose that after 3 consecutive yeses, a child has acquired the skill. Therefore, we would need to graph the number of acquired skills per week. Are you following me here? All right, so let's unpack this to clarify for you a little bit more. I've given you some information about the child here and what they've gained each week. By the end of January 1st, the child did not gain any skills. So your data sheet would look something like this. From December 26th until January 1st, the learner did not acquire any skills, as you can see. They're all no's. The following week, the learner acquired 2 skills. Here, you can see they acquired clapping and stomping. Now, I highlighted it in yellow so that we can see that it's been acquired. We do this on our data sheets and on the computer so that when counting it, it makes it so much easier. On January 14th, the learner acquired 3 skills: tap tummy, wave, and tap head. On the 4th week, ending on January 21st, the learner did not gain any skills. Now, how would this be graphed? With cumulative graphs, you're graphing the skill at the end of the week. Your y-axis is the cumulative number of skills acquired. In this case, it's imitative skills. The x-axis, again, is passage of time. In this case, it's weeks. So your first point will be at 0 for January 1st. The next week, 2 skills were acquired, so you'll go up by 2. The next week, 3 skills were acquired, so your graph will go up by 3, which will total 5 skills. Remember, cumulative records show the addition of skills from the previous weeks, and that is why we have 5 skills here. The last week, no skills were acquired, so then your graph would actually flatline right here. If your graph looks like this, then you graphed it correctly. Your graph should not have increased or decreased, but flatlined, as I told you before. Suppose your learner did not gain anything on week 5, 6, and 7. What would your graph look like? It should flatline like this, since no new skills have been acquired. Now, if you're using numbers or Excel to input the data, you would need to add the skills right on your table. For example, week 1, the learner has 0, then 2, then 5. You would have to put 5 because the learner gained 3, so you're actually doing the addition on Excel because it's not going to do it for you. When graphing your flat lines, since the learner did not gain any skills, they would remain at 5. So each week would be at 5 because they flatlined. Now let's move on to bar graphs. Now they're used to display things kind of like line graphs. A bar graph uses a horizontal or vertical bar. Bar graphs make comparisons between different variables, so it's easier to see. They clearly show trends in data showing how one variable is affected as the other rises or falls. We use bar graphs to present preference assessment data. This is something we'll talk about in a later class, but I just wanted to show you that. Look at cumulative graph A and compare it to B. Which one has a faster rate of acquisition, A or B? And the correct response is A. Way to go. Look at this cumulative graph. What's wrong with it? The graph shows a decrease, which is not possible in cumulative graphs. If you got this one right, give yourself a high five. Way to go. So we have come to the end of our graphing class. We covered a lot of valuable information, which will help us in practice. My final thoughts. Pay attention to your graphs and speak to your supervisor. I can't stress that enough. In our supervision class, I will speak about this more. But it's so important to talk to your supervisor about programs that are not moving or problem behaviors that are not improving. You may be able to address this with your supervisor so that you could catch the potential problem sooner than later. Collect your data so that you can graph it. If you don't collect data or you forget, you can't graph it. Then there's no data. When we need to question whether we are being ethical or not and giving our clients the best service, Often the number one problem with data collection is staff do not know what exactly the behavior is. When we get to discussing operational definitions, you'll understand the importance of a clearly defined behavior. Safety first. Remember, we love data. Baseline data is great to have, but if it's a dangerous behavior, you will need to speak to your supervisor to get help sooner than later. We don't want the client or staff to get injured. Variability is when data points are spread out from each other. This shows that there is a difference in scores, meaning that there is no stability. For example, a learner who gets 50% one day on their responding, followed by 80% the next day, followed by 20%, shows a lot of variability. Variability is important to us in practice because it allows us to question why is there that variability so that we can support our learner during teaching. A stable graph is one that shows data points are close to each other and that they're at the same level. The level is the position of the line along the y-axis. Levels can be high, moderate, or low. The trend is the direction of the data points. We can have increasing trend, decreasing trend, or no trend at all. I want to thank you for joining me today here at our graphing class. I hope you enjoyed it. Let's do some more practice. Okay, let's practice graphing. I've provided you with a blank graph, so make as many copies as you'd like. So here is some data. I've provided you with the dates and percentages. Let's assume this is data from a matching objects program. Be sure to put the correct labels on the graph and plot your points. So let's look at your graph. If we were graphing matching of objects, you would label your graph so we know what the program is. On the y-axis, you can label it as percentage of correctly matched objects. And be sure to number your y-axis in percentage and go up by tens. That's a good choice usually. And on the x-axis, you would put the dates. Now let's take a look at the data. Your first point is plotted at 20%. Your next point at 35%. Your next point is at 50%. And your last point is at 55%. Did you get the same? If you didn't, take a look at where you went wrong and regraph it just to practice. Let's try another one. Here are some data points. Label your graph correctly and plot the points. This program is an imitation program. So you would have to label your y-axis as percentage of correct imitation of actions or whatever the specific program is. Your data points are 10%, 44%, 35%, 50%, and 75%. Your x-axis should have the dates at the bottom. If your graph looks like this, well done. Let's continue. Go back to your first graph, but this time a revision was made. I'll show you the data. So the most important thing I would be looking at here is that you've added your condition or phase line. You labeled that there is a revision and you plotted your points. You also want to ensure that you didn't connect your dots over the condition line. If your graph looks like this, well done. Let's try graphing cumulative data. So here's the data for the month given each week. Graph it and pause the video if you feel you need more time. Now, if you were inputting it into the computer, it would look something like this. You would need to add the targets and put them in. If you didn't, it would graph it incorrectly. So the first week was 0, second week was 2, third week they gained 2 more skills and have a total of 4. The last week they gained 3 more skills. Add 3 to the previous 4, which is a total of 7. Did you get the same? What does your graph look like? If it looks like this, you did it. First, notice the y-axis label. Then your y-axis scale could go by 1s or 2s, up to 10 or 20, depending on the program. Here are a few more for you to practice. Good luck.